Hello, this is Mrs. Huntley. We're in the supplemental materials for Module 5. It says real number system on the front. You should be on page 17. And your essential question is, how do I classify real numbers? And you know what? Nobody's mentioned this to me yet, but we've been talking about real numbers for the last couple of weeks. And nobody said, well, of course they're real numbers. Why wouldn't they be real numbers? There is something called imaginary numbers that you're going to get into when you get into the higher levels of math. So we've been dealing with the real number system, and all of the numbers you've been learning about since you've been learning about numbers have been real numbers. So now we're going to talk about classifying them, and it's a way of putting numbers into a category, and then each number fits into a category based on specific attributes or features of the number. So this gets a little bit confusing, and honestly, it messes with my head a little bit. It's just a matter of remembering the order of the categories. So let's take a look at some examples here. And the way uh, this lesson teaches it is actually kind of cool because it talks about a different kind of real world example. So let's look at page 18, and it's the introduction. It says, over the summer, Ethan spent a week at an overnight camp. He ended up meeting tons of friends, and some ended up being people that he goes to school with this year. On the first day of school, he recognized one of his camp friends in his math class. Other friends he met at camp live in different states, but they still kept in touch with each other throughout the year. Task 1. In no particular order, the headings below describe the different types of friends that Ethan met at camp. Using the graphic organizer below, see if you can place each of the headings in the box where they belong. So let's take a look. Friends from camp is the entire thing, okay? And then we have subcategories that would kind of divvy up the friends from camp that he might have met. So thinking about whether his friends from camp are going to be in the same class that he goes to. If they're in the same class, are they going to be from the same city or the same state? And we have same school. So these are all of our categories. So it goes from being very general, all the friends that he met at camp, the most general you could be. And then the state would be the next most specific. So were they from the same state or from out of state? Out of state would mean like a different state. So let's do, that would be the next most specific category. So let's say same state. And this would be our different state or out of state. Now, if they're from the same state, the next most specific category, actually I'm going to cross these out so we don't think like we have to use them again. So same state is gone and out of state is gone. So what's the next most specific category? Would it be same city, same class, or same school? What's the next most general? I'm thinking it's going to be same city. So same city is going to come next. If they're from the same city, they're of course going to be in the same state, and they're going to be friends from camp because he of course met them there. So let's cross this one out. Oops, it works better if you use a pen. There we go. Now the next most specific would be the same school, right? And finally, the most specific it could be would be his same class. Does that kind of sort of make sense? So if you're in the same class, of course you're going to be going to the same school. Of course you're going to be in the same city. Now I know some of us live in different cities around this school, but for the most part, your school is in the city that you live in, usually. And if you're living in the same city, of course you're going to be in the same state. And if you had all of those things in common and you also saw him at camp, you're going to fit in this larger box. Okay? Now over here, we've got the box of friends that he met from camp that live out of the state that he lives in. So if they don't live in the state that he lives in, they of course can't live in the same city or the same school or the same class. I hope that kind of makes sense. Is it possible for a friend in the same class to go to a different school? So can you be in this class but not be going to this school? No, because the class fits inside the school. So that would be no. Is it possible for a friend in the same state to go to a different school? So we're just here at the state box. Could there be more than one school in a state? Yes, of course there could. So just because they live or they're in the same state doesn't mean they're also going to be in the same class. Ryan is one of Ethan's camp friends who is also in his first period class. So they're in the same class. Write Ryan's name in all of the boxes where he'd be included. Okay, so Ryan is in the same class. So that means Ryan also goes to the same school. He also lives in the same city. He's also from the same state. And he was a friend from camp. So Ryan is actually a member of all of these boxes. But since he's in this most specific box, we know that he's included in all of those other boxes as well. Let's take a look at how this relates to numbers. So let's switch the page real quick. Let's talk about real numbers. What are our categories of real numbers? The most specific category is natural numbers. This is the set of all positive counting numbers on the number line starting with 1. So examples of positive counting numbers would be 1, 2, 3, etc. Okay? Whole numbers include all of the counting numbers, but it starts with 0 instead of 1. So whole numbers would be the 1, 2, 3, but also 0.
Francisco, please come to the main office. Michelle, please come to the main office.
So 0 plus all natural numbers. Integers, a set of whole numbers and their opposites. So we'd have 0, of course, 1 and -1, 2 and -2. Okay, though the 1 and the 2 are already included there because they're natural numbers. So I technically, I guess, didn't have to write those there. Hopefully you weren't tracking with me too closely. Let's just put the negatives in here because we know that all of those other ones are in there as well. So -1, -2, -3, etc. Rational numbers, we learned about this already. Numbers that can be written as fractions, terminating decimals and repeating decimals, and perfect squares. So some examples of those would be 1/3, 0.3 repeating, and the square root of 25. Those are just some examples. It's not an all-inclusive list. Irrational numbers, numbers that cannot be written as fractions, non-terminating, non-repeating decimals, and non-perfect squares. So what are some irrational numbers? Pi and the square root of 2. Okay, so again, most specific, going to least less specific, all of them fall under in the big box of real numbers. So let's name our categories first of all. Irrational is over here. And rational would be over here. That's our most general. Our next most specific category from rational is going to be integers. And I've got whole numbers. Whole numbers include 0. And then here we have natural numbers. Okay, now they're asking us to put some numbers in. Place the headings for each type of number in the graphic organizer, then see if you can correctly place each of the following values into the box where they belong. So let's look at this. 2 times the square root of 64. The square root of 64 is a perfect square, so that's going to fall in the rational box. So 2 Square root of 64. Square root of 64 is 8. 2 times 8, that would be 16. So that would definitely fall in there. Negative 15. Let's see, integers are the sets of whole numbers and their opposites. So negative 15 would be an integer. 16 divided by 4. 16 divided by 4. Let's think about this. 16 divided by 4 is 4. That is technically a whole number, isn't it? Because that is a whole number answer, I'm going to put it in the whole number category. The square root of 75 is an irrational number. 0 is also a whole number. Negative 12.2. Oh, you know what? I should have put 16 divided by 4 in natural numbers because 4 is a counting number. My apologies. It would fall under both, but I just wasn't thinking about it clearly enough. So that's going to be a natural number because the answer is 4. Whole number would be 0. Integer is negative 15. Rational is 2 times the square root of 64. Negative 2.2 is also going to be an integer. Let's see. 12.2, I apologize. And that is all of the numbers. And I think we have a number in every category, don't we? And they're all real numbers. So they all fall in the huge box of real numbers. But as we get more specific, they fall into specific categories. And of course, sometimes you make mistakes when you're thinking about the difference between whole numbers and natural numbers. The only number that's going to be in the whole number box that is not in the natural numbers box is going to be 0. So 16 divided by 4 is a whole number, but it's also a natural number because it is a counting number of 4. Hopefully that makes a little bit of sense. And let's take a look at the next page. We're just going to go ahead and do this. Actually, I'm going to have you pause, and I'll do some with you, and then I'll have you pause as well. So let's take a look here. Classify the numbers in the table by checking all that apply. So they're all going to have multiple categories checked. Negative 6 75 hundredths. Is that going to be a, first of all, they're real numbers. Is it rational or irrational? Let's pick here first. Let's see, it's a terminating decimal, so I'm going to say it's rational. And it's a negative, so I'm going to say it's also an integer. So that fits into 3 categories. The square root of 175, it's a real number. Is that going to be rational or irrational? Is it a perfect square? It is not a perfect square, so it's going to be irrational. Those are the only 2 categories that one's going to fall in. 5 times pi. You know what? Why don't you do the next 3 and then come back and check your work. So pause the video real quick, check the boxes for the next 3, see how you do, and then come back and check your work. Okay, instead of filling them in and having you come back to them all filled in, I just wanted to talk through it. So 5 times pi, again, real number. Pi is an irrational number, so those are the 2 boxes you should have checked. 30 divided by 3. Let's see, 30 divided by 3 is going to be 10. It's a real number. It's a rational number. It's an integer. It's a whole number. And it's a natural number. So the only one it's not is irrational. The opposite of the square root of 9, or the negative square root of 9, it's a real number. It's going to be rational because it is a perfect square. It's an integer. And it's a whole number. Because that is, oh, I'm sorry, it's not a whole number. Ding, 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 I'm wrong. Because it's negative. It's going to be negative 3. So integer would be the integer, rational, and real for that last one. Okay. Rachel states that negative 5.5 is an integer because it is negative. Is she correct? Why or why not? sorry, I got distracted. I apologize. Rachel states that negative 5.5 is an integer because it is negative. Is she correct? Why or why not? I'd say yes, she's correct, because a negative or an integer can be a positive or negative number. So the being that it's negative, it's going to be an integer. Jeremy says that 5.676677666777 is a rational number because it's a decimal that goes on forever with a pattern. Is he correct? Why or why not? Hopefully you know the answer to this one because we did have some problems like this in the last lesson. No, it's not a repeating pattern. Therefore, it is not a rational number. It is irrational. Okay, the graphic organizer represents all real numbers. Which would be the value of D? Okay, so D is our ring. That would be for whole numbers. So which would fall into whole numbers? So the only whole number that's not a natural number is going to be B. This is which could not be in the value of B, which is this one out here. And we said, you know what, I'm going to label these because this is hard without it being labeled. This is natural, whole, integer, rational, real, and this is irrational. Okay, so which could not be in the value of B? Rational. So what's not rational? One that is not a perfect square. Give an example of a value that could be represented by A, an irrational number. First one that comes to mind for me would be pi. Of course, there are many, many, many others. I just went a little bit over because I just did this last page with you. And we're going to call the lesson here over. Sorry, we're going almost to 18 minutes, but we're still less than 20, so I'm still better than I used to be. I hope you enjoyed this lesson. I will see you tomorrow. Bye.